Now we play the math game. Not the match game, the math game. And so we're going to multiply 0.1 minus x to both sides. That cancels out. This is really easy to do in my head here. This is 4.4 times 10 to the negative 5 minus 4.4 times 10 to the negative 4x. And then we multiply this out, x squared plus 0.15x. And again, we could probably drop the 0.15, but I'm not going to do it. We're just going to play this out. So we're going to add a negative x squared here. In front of this, we're going to move this behind. That's going to go over there. And the 0.15x, we're going to subtract the x squared minus 0.15x minus 0.15x. And looky here. Yeah, this is still gonna be slightly different than up there. When you subtract that, you're gonna get 0.151496. That's gonna be the same thing. I'll do that with my calculator. You get the same thing. We probably just go ahead and take care of that right up there. Let's do that. So negative 0.15, I may have subtracted instead of add, I think I did. Minus 4.4 e negative 4, and we get 0.150. What do we get up here? 0.150. Well, it doesn't change. Okay. Well, we'll do it anyway. But you probably could drop the x of that. Yeah. We'll just continue on with this. So we got negative x squared minus 0.150x plus 4.4 times 10 to the negative fifth equals 0. Plot form that puppy. Negative 1 for A, negative 0.15 for B, and 4.4 E negative 5 for C. And we get 2.93 times 10 to the negative 4. Well, what does X represent? Well, let's go back and see. X represents not H, but OH. So that's a concentration of OH negative. Okay? So, instead of pH, we're going to have to come up with POH to begin with. That's a negative log of that number right there. We did negative log second, answer, and I got 3.53. But that's not what we're looking for here. We're asked to find the POH, or the pH rather. So we take 14 minus the POH, which is 3.53, and we get 10.47. And this is a situation I want you to understand. All my pHs, I want 2 decimal places for. Not 3, not 1, not 0. I want 2 decimal places. Okay? So, in fact, I think we could have simplified that. Like I said, we could have dropped the x with the 0.1 and the x with the 0.15. What the heck? Let's do it anyway. Let's do that anyway. I think we're going to get the same answer. So, we've got, let's go back here, 4.4 times 10 to the negative 4 is equal to, and we got x plus 0.15 times x over 0.1 minus x. And we know that the x is going to be a really small number, And we saw that it basically doesn't really change much. So that means if you subtract x, which is a really small number, from 0.1, that's going to leave you 0.1. If you have x, which is a really small number, much smaller than 0.15 than it was for 0.1, we're going to drop that out. Now we can't drop that out because that's not adding to one of the two numbers. You've got to add or subtract to one of the two numbers involved in the common ion. What this is going to give us then, 0.15 divided by 0.1, which is 1.5x. So then I divide both sides by 1.5. And x then equals 4.4 e negative 4 divided by 1.5, and we get 2.93 times 10 to the negative 4. And what did we get up here? 2.93 times 10 to the negative 4. It works. Well, man, we can drop that when it's adding or subtracting a fairly decently sized number in comparison to your Ka or Kb. So, keep that in mind. Your practice problems, wait, did I do them all? Yeah, 65, okay. So, your practice problems then are on page 763, problems 62 through 66 even. Have fun!